Hi everyone, this is the video lecture for the next chapter in Math 101, which is Algebra. We're going to start off with just a little introduction in this video, and this is going to correspond to the homework for chapter sections 2.6, 2.7, and 5.3. So first, we need to talk about some vocabulary. When you're dealing with algebra, you're going to see the letters now involved. So those are called variables. A variable is a letter that represents a number that you don't know. Oftentimes you can solve for it and find it, other times you can't. It's just a placeholder for a number that you don't know. An expression is when you combine variables together with regular numbers with addition, subtraction, multiplication, and division signs. And this entire thing together, for example, 2x plus 3 would be considered an expression, just like 2y squared minus 7xy plus z is also, when you look at it as a whole, that's considered an expression. Within the parts of an expression, you can look at individual pieces, and those are called terms. So for example, 2x squared would be the first term, and then 3y squared would be term 2. The xy is the third term, and the 4 is the fourth term. Next is the word coefficient. Coefficients are the numbers that are in front of a variable, and it means multiplication. So in the expression 2x, the 2 is the coefficient, and it means 2 times x. In the second example here, when you're just looking at a variable like y, if you don't see a number in front, it's assumed that it's a 1. So y would have a coefficient of 1, and it just means 1y. And in the third example here, you can also have negative coefficients. It just means negative 3 times x times y. Whatever x and y are, you would multiply that all together. Then there's something called like terms. So we know that terms are the pieces of an expression, and they're separated by addition and subtraction signs. When terms are considered like terms, it means that they have exactly the same variable raised to exactly the same power. And if they are like terms, you can combine them with addition or subtraction. Evaluating is the last thing on this topic here. And when you're asked to evaluate an expression, you'll be given an expression with variables in it, and then you'll be given the values of the variables, and you'll need to substitute in the numbers in place of the variable and then solve it using the order of operations. Okay, so we're going to start off with evaluating. The first set of guided practice problems say, evaluate each of the following algebraic expressions if x equals 2, y equals 1, and z equals negative 3. And remember to follow the order of operations. So for all of these, you'll be given the values. X is 2, y is 1, and z is negative 3. You're going to replace those variables that you see then in each expression with the numbers that they gave us, and then we're going to work it out. So when I first start, what I like to do is take out all of the variables that I see and put parentheses in their spots. So instead of an x, I'm writing a set of parentheses. Instead of a y, I'm going to write another set of parentheses. And instead of a z, I have that third set of parentheses. Whatever my x is then is going to go in here, which is a 2. Whatever my y is going to go in this spot, which is a 1. Whatever my z is will go in the third spot, which is negative 3. So I substitute first, and then I'm going to work this out. Since all of these letters and numbers are all right next to each other, that means multiplication through the whole thing. So all I need to do is plug this all in and multiply it together. So I typed it in just the way that I saw it on paper, and it gave me an answer of negative 12. one's done. Let's look at number 2. We're going to use the same values for x, y, and z as we just did, substituting into this expression now. So first, I'm going to plug in my x. My x is a 2. My y is a 1. So I need 1 there and 1 there. And my z is negative 3. So when you plug this in, you need to be very careful that you account for the subtraction sign that was part of the expression and the negative sign that's part of the number. So it looks something like this. Now I'm going to plug this all into my calculator. And that gave me 12. Now, if you were to do this by hand without plugging it into the calculator the exact way that we used the parentheses, you would have to follow the order of operations. That you do your parentheses first, then any exponents that you have, then multiplication and division left to right, and then adding and subtracting. So in this case, I have 2 plus 1, which is 3, times 1 minus negative 3 is like adding. So that's a 4. And then 3 times 4 is where the 12 comes from. Okay, for number 3, we're going to do the same thing. We're going to take the variables out and put parentheses in their place, and then substitute the numbers that we were given. So in place of x, we need a 2, and in place of this z, we need a negative 3. Then following the order of operations, I know I need to do inside my parentheses first, but inside I only have a 2 and a negative 3. So I'm going to move on and do the exponents. So this and this will come first. 2 squared is 4. And negative 3 squared inside the parentheses is positive 9. And I'm going to bring everything else down. Now I'm on to multiplication. So I see multiplication here and here. 3 times 4 is 12. And 4 times 9 is 36. Last, now I can add this up. And my final answer is 48. And I plugged it into my calculator to check, just the way I wrote it on the paper, and it checks out. So that one's done. And for number 4, I'm just going to do the same thing and replace my variables with their numbers, substituting in x is a 2, y is 1, and z is negative 3. So I replaced that, and that. And now I'm going to work it out with the order of operations, starting with the inside of the parentheses first. Inside of here, I see addition and multiplication. So I'm going to start right here. So that's a 2 times negative 3, which is negative 6. And then I'm going to bring the rest of it down. And then I'm going to go left to right and add this all up. So 2 plus 1 is 3, and 3 plus negative 6 is negative 3. That takes care of the inside of my parentheses. And then I'm going to bring everything else down that I haven't used yet. And take another look. So next, I need to finish the multiplication right here. 4 times negative 3 is negative 12. And then add this up. Positive 2 plus negative 12 is negative 10. And there's my final answer. Let's check it with the calculator. So I plugged it in the way that I had substituted it in originally. And I get negative 10, so that checks out, and that's done. Example 5 says the cost of attending a sporting event is $25 for adults and $15 for students. The total cost of A adult tickets and S student tickets can be calculated by using the expression 25A plus 15S. If 12 adult tickets and 10 student tickets were purchased, what was the total cost of the tickets? So in a problem like this, they're giving you an expression to work with off the bat. So I'm going to pull this out, write it down, and I'm going to write off to the side what each of these represents. A is the adult tickets, and S is the student tickets. And now I'm going to substitute in the amount of adult tickets that they told me and the amount of student tickets that they told me into this expression, and I should be able to solve it and come up with a number. So I'm going to replace the A with a set of parentheses and the S, and then I'm going to substitute in the numbers. There's 12 adults, so that goes here in place of A, and there are 10 student tickets, so that goes there in place of S. Now I'm going to follow the order of operations and work this out. So I see multiplication right here and here, so I'm going to multiply that first. 25 times 12 is 300, and 15 times 10 is 150. So add that up, and it's $450. Checking it with my calculator, I plugged in this line right here where we substituted, and I got 450, so this one's done. Number 6 says the perimeter of a rectangle can be found by using the formula 2L plus 2W, where L is the length of the rectangle and W is the width. What is the perimeter of a rectangle that has a length of 17 inches and a width of 15 inches? Just like the last one, I'm going to pull out the expression that they gave me. I'm going to jot down off to the side of what each of these represents, just so I don't get confused, although this one is very self-explanatory. And then I'm going to substitute in place of my L and my W. So they told me that the length is 17 inches and the width is 15. So plugging it in, and then I'm going to multiply it out. So 2 times 17 is 34. 2 times 15 is 30, which means that altogether this is 64 inches. I plugged it in after I substituted, and I get the same thing. So that one checks too. Number 7 is a little bit more complicated, so let's take a look. It says a bottle of medicine contains 0.5 kilograms of the medicine. One dose of the medicine is 20 grams for a child and 45 grams for an adult. The number of grams used can be calculated with the formula 20C plus 45A, where A is the number of adult doses and C is the number of child doses. If a medical assistant needs to give a dose of the medicine to 12 adults and 10 children, will there be enough medicine in the bottle? And if not, how many more grams will be needed? All right, so the first thing we're going to do is pull out the expression that we have here. And we're going to jot down what each variable means. Next, I'm going to substitute in place of my C and my A. So they told me that we are going to give this to 10 children. So I need to replace the C with a 10 and 12 adults. Then I'm going to work this out with the order of operations. So I'm going to multiply both of those. And let's see what we get. So 20 times 10 is 200. And 45 times 12 is 540. If I add this up, that means I get 740 grams. So let's go back. The medical assistant needs to give a dose to this many adults and 10 children, which means that we need a total of 740 grams in order to give it to this many people. Let's see if we have enough. The bottle has 0.5 kilograms in it. That doesn't match with the unit that we were given. So what I'm going to do is take the 0.5 kilograms and convert it to grams using the metric prefix line, because these are both metric, and that'll tell me how much we actually have to use. So metric prefix line looks like this. Base unit in this case is the gram. We're starting at kilogram and we're going to change it to gram by moving the decimal 3 places over to the right. Starting in front of the 5, we'll move that 3 times. 1, 2, 3. I need to add a couple zeros. And now we have 500 grams. So the bottle contains 500, but we need 740. So no, there will not be enough medicine. And when we subtract, we'll need 240 more grams. Okay, moving on to the second topic for this, we're going to talk about like terms versus not like terms now. So this is going to be used when you're simplifying expressions. When you do have like terms, you can add them and subtract them. If you don't have like terms, you can't do anything with them. So first we need to decide what is what. Going back to the definition, like terms are two terms that have the exact same variable with the exact same exponent attached. So if we look at choice A right now, we have negative 5y and 6y squared. Those are not like terms because although they both have a y, one is squared and one is not. So A is not like terms. For B, you have 3mn and mn over 2. You're looking at each variable and comparing it one by one. These both have an m and they both have an n. The fact that there's a 3 in front of the first one and this one's being divided by 2 has nothing to do with this. These are considered like terms. For C, you're looking at 14 and negative 8. There are no variables at all. So these two are considered constants. That's what we call regular numbers with no variables. And since you don't have any variables, there's nothing there that is not the same. Constants are always like terms. For D, you have 9x squared y to the third and 12x to the third y squared. So you have x and y in both of them, but the exponents that are attached to each one don't match. This first one has a 2, the second one has a 3 attached to the x, for example. So those are not like terms. In E, you have 7a to the 5th, b to the 3rd, c, and 10a to the 5th, b to the 3rd. These are not like terms because the second one is missing the c. And the last one is 5p to the 2nd, q to the 4th, r to the 3rd, and 3q to the 4th, r to the 3rd, p to the 2nd. These are like terms because even though they're in a different order, they both have a p squared, they both have a q to the 4th, and they both have an r to the 3rd. The order doesn't make a difference. They are like terms. So now that we have sorted through what's like terms and what is not like terms, let's talk about how you simplify an expression by combining them. You have an expression here, 8x plus 3y minus 3x plus 4y, and they're asking you to simplify it. What they mean is put together things that are the same and combine this together and make it a little shorter, make it look more simple. So first we need to identify the like terms that we have. First, I see these x values here both have just an x, and these other two terms both have y. So those can be put together. When you combine them, it's like you are moving the coefficients together. So this is really 8 minus 3 with an x after, and this is a positive 3 plus 4 with a y at the end of it when you combine it. So 8 minus 3 is 5, and 3 plus 4 is 7. So your final answer is 5x plus 7y. And you can't combine these any further because these are not like terms now. This one has an x, this one has a y. Those variables are not the same, so you can't combine them. This is done. Let's look at another one. This one uses what's called the distributive property. The distributive property is used when you're trying to simplify expressions and you can't combine like terms on the inside of a parentheses. What you can do instead then is take a number that's in front with its sign, like this right here, this positive 2, and multiply it to everything on the inside of the parentheses. It's called distributing the 2 to everything inside. So this is what it would look like first. This positive 2 is going to get multiplied to x, and then this positive 2 is going to get multiplied to this minus 4 here. We're not doing anything with this 3x yet. We're just going to bring it down, and it'll look like this. 2 times x is 2x, and then 2 times this minus 4. Think of this as positive 2 times negative 4, which would be negative.
and then I multiplied this out. Now I can simplify this even further because I see I have like terms right here. The 3x plus the 2x can be combined together, making 5x minus 8. And this is your final answer. You can't go any further because 5x and 8 are not like terms. Here's one more. Now when you use the distributive property, you've got to make sure you're distributing whatever's directly in front of your parentheses. I see a 4 here, then I see a minus sign. This minus sign is what's directly in front. Anytime you see something like this, think of this as a minus 1, a negative 1. So we're going to distribute that negative sign to everything inside, like it's a negative 1. So starting with the x, this becomes negative x. And then this negative times this negative is going to change our final answer here. So negative x minus negative 6. The two negatives change that to a positive. And then I can combine the like terms that I see here. I see these two constants that can be put together. When you combine, you take the signs right in front. This plus goes with the 6 only. This minus sign is with this x. So this is 4 plus 6, which is 10 minus x. Usually we write the variables first, so you could at the end switch this around. This is a negative x. This is a positive 10. So you could write it as negative x plus 10 also. Those are equivalent.
Okay, to move on to the guided practice problems, number 1, they want you to simplify this by either combining like terms or using the distributive property. Since these are all like terms, they all have an x. 3x plus a 2x minus an x can be thought of as a 1x. I can just go left to right with these. So 2 plus 3 is 5, and then 5 minus 1 is 4. And number 2, when I look inside the parentheses here, I see I can't combine this. I can't combine 3x and 5 because 5 doesn't have an x. So this is an instance where I'm going to use the distributive property. I'm going to take the number in front and multiply it to everything on the inside. So 4 times 3x is 12x, and 4 times negative 5 is negative 20. I'm going to write it as a minus 20. Now I'm going to take a look and see if I can do anything else. This has an x, this does not, so there's nothing else I can do. That's as simplified as I can get it. For the next one, I see I have parentheses here, but I can't combine 3x and 4, just like I couldn't do in the last problem. So I'm going to distribute what's directly in front of my parentheses to get rid of those. The thing of directly in front is that negative sign. Think of it as a negative 1. When you distribute this, that becomes negative 1 times 3x, which is negative 3x, and then negative 1 times positive 4 is negative 4. I haven't done anything with that 5x yet, so I'm going to bring that down. Okay, next I see I have some terms that I can combine. The 5x and this minus 3x are like terms, so I can put them together by subtracting their coefficients. 5 minus 3 is 2x, and then I bring down the negative 4 or the minus 4. Those can be combined because they are not like terms, so this is your final answer. And for this last one, this time you have brackets here and parentheses. Just like with any order of operations problem, you need to work from the innermost set of parentheses on out. So we're going to first try to get rid of these inside parentheses. I can't combine the x and then minus 3. So what I will need to do is distribute what's in front, which is this negative sign or the minus sign. Since there's no number with it, we're going to treat it like it's a negative 1, and that's what's going to get distributed to the inside set of parentheses. So it's negative 1 times x, which is negative x, and then it's negative 1 times negative 3, and a negative times a negative is a positive. That takes care of the innermost parentheses. I'm going to bring everything else down now that I haven't used yet. So I still have an 8x. I still have a plus 2. I still have the brackets. And this 5 is still there. And that's it for now. Now, inside of these parentheses, or these brackets, I see like terms that can be combined. So anytime I can combine, I'm going to do that first because it's less distributing to do later. So this is a 5 plus a 3, which is 8. And then I'll bring down the minus x and everything else that I haven't used yet. That's as much as I can combine, so now the only way to get rid of these brackets then is to distribute again. So I'm going to take my number in front with its sign, so we're going to take this as a positive 2 and distribute it to everything on the inside. So 2 times 8 is 16, and then 2 times negative x is like a negative 1x. 2 times negative 1 is negative 2x. And I still have this 8x in front that I haven't done anything with. So I'm going to bring that down. Now, I've got to make sure that I put a sign in front of this. Since this was positive 16, 2 times 8 is positive 16. I'm going to write a plus sign in there and make sure I keep track of everything I'm doing here. Finally, all of the parentheses and all of the brackets are cleared. Now I'm going to take one more look at it and see if there's anything else I can do. I see like terms that can be combined again right here. And take the sign in front of each one when you do this. It's a positive 8 minus 2. 8 minus 2 is 6. X plus 16. Those are not like terms. They cannot be combined. So this is your final answer. And that one's done. On this last page is just more practice problems for simplifying. So for number 5, I see like terms I can combine. I have a 2x plus a 7x that can be put together. That'll give me 9x. And then I see a negative 5 minus 3. I can put those together. Negative 5 minus 3 is negative 8y. Those are not like terms. Those cannot be combined any further, so that one's done. On to number 6. I see parentheses, but inside I cannot combine anything, so I'm going to distribute the 3 to clear out the parentheses. 3 times c is 3c, and 3 times 4 is 12. That'll clear out the parentheses. I'm going to bring down the 3c back because that's not inside. That's not going to get distributed. and then I'm going to look and see what I can combine. I see these terms here, 3c plus 3c, both have c. Those are like terms. I can put them together. 3 plus 3 is 6. C plus the 12. And that one's done. On to number 7. Number 7, I see parentheses, but inside I cannot combine anything. So I'm going to just start with distributing. So take this -2 that's in front and distribute it first to the A. -2 times, this is a 1A, is -2A. Then -2 times positive 4B. -2 times positive 4 is -8B. Bring everything else down that you haven't used yet. So 2A plus 3B is being brought down. And then we're going to take another look and see if we can combine anything. I see a term here and an a term here. 2A minus 2A is 0A. So these canceled out. A's are gone. And the B's have a positive 3B and a -8B. Those can be put together. Positive 3 minus 8 is -5B. And last but not least, we have one similar to the other page where you have parentheses and brackets. So you need to work from the inside out, starting with distributing this negative sign. Think of it as a -1 or a -1 and distribute that to your inside parentheses. So -1 times x is -1x. Then -1 times -2, negative times a negative is a positive 2. That clears the inside set of parentheses, and I'm going to bring everything else down now. Okay, so here's what's left. I'm going to take another look inside of the brackets because I see the 7 can be combined with the 2. So I'm going to put those together, combine those like terms. 7 plus 2 is 9. Minus the 1x. And next, I got to distribute the 4 to clear out my brackets. So take this positive 4, multiply it to the 9. 4 times 9 is 36. And distribute this 4 to the -1. Positive 4 times -1 is -4x. And I'm going to drop down the 6x in front. Now this was a positive 36, so I'm going to write it as plus. And one more time, I see like terms that I can combine right here. 6x minus the 4x. 6 minus 4 is 2x plus 36. And that's all done. And that's the end of this section.